Hi, I'm David Wilmer, Director of Technical Product Marketing at Matillion. Today, I am going to show you how to get started building orchestration and transformation pipelines in Matillion Data Productivity Cloud Designer. The goal of the exercise is to load data from multiple sources into a Snowflake data warehouse, then transform the data to calculate profit and revenue over time. Starting from the Matillion Hub, access the Matillion Data Productivity Cloud Designer by clicking on Design Data Pipelines, and then choose the project to work in. Because Matillion Data Productivity Cloud is tightly integrated with Git, collaboration is inherent and seamless. In Project Explorer, every project starts with a main code branch. This is the repository where all finalized code should reside. Therefore, I will build my pipelines in a development branch and later merge them into the main code branch. Clicking on the development branch opens the Matillion Designer. I have already created this simple transformation pipeline. It populates a list of dataset names into a Snowflake table that will be referenced in a later orchestration pipeline. Executing this pipeline will create the table in Snowflake and load the values. Now, I want to build an orchestration pipeline that loads my source data into Snowflake. Orchestration pipelines allow me to coordinate the tasks associated with data integration. I can extract, load, and transform data, manipulate data objects and resources, and better control the flow of my data. To create a new orchestration pipeline, click on the plus sign in the upper right corner of the Pipelines pane and select Add New Orchestration Pipeline. This opens a blank canvas where I can begin designing my data flow. Here, in the lower left corner of the designer, the Components pane provides a dynamic list of components based on the type of pipeline I am creating. For this orchestration pipeline, I first need to create a table in my data warehouse, so I will locate the Create Table component and drag and drop it onto the canvas, connecting it to the Start component. Clicking on a component in the canvas brings up that component's properties. This is where I will set the parameter values that define what the component does within the pipeline. For this component, I will provide a meaningful name, set the Create Replace parameter to replace, and set the new table name parameter, the table name that will be created in Snowflake. Finally, I can define my table columns. This table is a single column table that will store raw JSON data as a variant data type in Snowflake. Once I run this pipeline, the table will be created and available to reference as I continue building out this orchestration. Now it is time to load some data. The first set of data I will load is a JSON file from an S3 bucket. So I will drag an S3 load component onto the canvas and connect it to the Create Customer Accounts component. Many components in an orchestration pipeline have three possible output paths. Green is success, indicating the next step if the component completes successfully. Gray is unconditional. This means it will travel this path no matter what the outcome of the component is. Finally, the red path is for errors, indicating the path needed should the component fail. This is great for error logging and recovery tasks. Today, we will stick mostly with the green path. To configure this S3 load component, the first step is to provide a meaningful name and then specify the details of the JSON file location. The first value is the S3 object prefix, the root location of the file. Then the pattern. If I had multiple files of type JSON, I could specify star.json and load all of the files simultaneously. But I only have a single file, so I will just spell it out explicitly. I need to instruct the component where to load the data, so I will populate the target table parameter with the appropriate value. Notice that because I am constantly connected and interacting with my Snowflake instance, the component can pull the available metadata in real time, so I can choose the customer accounts table that I just created and know that I have the right object. With this path complete, I can now build a second load path. This second load path will use a powerful Matillion capability that leverages variables to load multiple datasets with a single component simultaneously. First, I will drag the pre-configured transformation pipeline onto the canvas and connect it to the Start component. Remember, this pipeline populates a list of dataset names into a Snowflake table. Before I add the next component, I want to create a pipeline variable to dynamically control the datasets loaded through this load path. Clicking on the X lets me manage my variables, including creating a new variable for this pipeline. Following the Create a Variable form, I can easily define this variable and click Create. With this variable, I can loop through the table names to load those datasets. Let me show how this is done. First, I will drag an iterate component onto the canvas. A table iterator will work best for this pipeline because I will loop through a list of table names passed into the table iterator component based on the target table parameter value. By setting the column mapping parameter, I can map the values from the table names table to the pipeline variable I just created. You may have also noticed I set the concurrency parameter value to concurrent. This means all tables identified in the table names table will load simultaneously, saving me significant time in the load process. Since my dataset for this load path is a series of tabs in an Excel spreadsheet, the last component I will drop onto the canvas is the Excel query component. Connecting it to the table iterator component allows this orchestration pipeline to simultaneously load all tabs of the data. As this component is configured, notice the key locations where I utilize the defined pipeline variable, specifically in the SQL query parameter value and the target table parameter value. Now I can validate and execute this pipeline to load all the raw data into Snowflake. When completed, I can drill into the task history of this execution and see at a granular level all the tasks and their status. It looks like everything was successful. Getting all my data into Snowflake is only half of the work. Now this data needs to be transformed to deliver meaningful insights. So I want to create a transformation pipeline to manipulate this data to my desired outcomes. Similar to creating an orchestration pipeline, click the plus sign in the upper right corner of the Pipelines pane, and this time select Add New Transformation Pipeline. Naming the pipeline and clicking Add opens a blank canvas. Notice a different set of available components. Transformation pipeline always starts with a read component, and since I want to read from 4 different datasets in my Snowflake instance, I will drag 4 table input components onto the canvas and configure them to the 4 sources of my data. The first is the customer accounts dataset that contains my raw JSON data. The database and schema parameter values are set to environment default. These values are set based on the configuration of the Snowflake environment I am connected to, which in this case is the development environment. The target table pulls the table name metadata from Snowflake in real time, so I can be sure to choose the correct table. Similarly, the column names parameter reads the column metadata, making it easy to identify the columns of data I need to select. The next 3 table input components will read data from the orders, items, and order items tables, so I will configure those accordingly. A powerful feature within Matillion Data Productivity Cloud is the ability to sample data in real time at any step of the transformation pipeline. After configuring these table input components, I can sample the data to not only ensure I am working with the correct dataset, but also to confirm the quality of the data. Now that I know what my data looks like, I can begin transforming it. The first thing I want to do is make sense of the JSON dataset containing my customer data. Matillion has a great component called Extract Nested Data that allows me to do just that. With this component, I can define each element of the JSON data and structure it into a standard row and column table, making it much easier to work with. Matillion also has the option to autofill the data elements by analyzing the dataset in real time. Now that all the data is in a fully structured format, I can join the datasets together with the join component. The join component is a powerful tool that allows me to define multiple join conditions in a single component. After defining the tables that need to be joined together, the join expression parameter lets me define the exact join expression. These expressions can be built in just a few simple clicks using the available fields and functions identified in the Join Expression pop-up. But in the interest of time, I am simply pasting each expression into its respective expression editor. With all the data joined together, I can now specify the columns I want to come out of this join, reducing the clutter of unnecessary data elements being processed through the pipeline. Pushing the data into a calculator component, I can now perform complex calculations to help analyze the data. And just like the join component, I can build complex calculations in just a few simple clicks using the available fields and functions identified in the calculations pop-up. Or I can leverage my high coding skills and type out the expressions directly into the calculations editor for each defined expression. Sampling the data at this point in the pipeline, I can see the calculations have been performed, and I can verify that the data is valid. At this point, I have calculated the profit and revenue of each transaction, but my business team would really like a profit and revenue analysis broken down by the account, the product, and the month. So I will configure this aggregate component accordingly, grouping on product name, account name, and order month, then choosing to sum the profit and revenue. Since this data looks good, I am ready to write this data out to a Snowflake table and operationalize the entire process. So back in the GreenWave Tech Performance orchestration pipeline, I will build this pipeline out a bit further to incorporate the transformation pipeline. Because I want to ensure the transformation pipeline has all the source data before calculating the profit and revenue, I will use this AND component. This component ensures that all upstream data streams are complete before allowing the next component to start. In this case, that next component is the transformation pipeline that was just completed. Now I can productionalize this pipeline. Right now, all of my code for this pipeline is in a personal development workspace managed by Matillion Data Productivity Cloud. So the first thing I need to do is commit the code to the remote Git repository so it can be shared across the development team and testing environments. To merge this code into another branch, I can choose Merge from the Git dropdown to manage the code migration process. Typically, a proper QA workflow would require development code to go into a testing environment, but in the interest of time, I will merge these changes to the main code branch so that this process can be productionalized. Choosing Publish Pipelines will allow me to schedule pipeline execution on a regular cadence. Switching to the main branch, I can pull remote changes and confirm that all pipelines are available. Now, back in the Project Explorer, I can select the Schedules tab to create an execution cadence for this orchestration pipeline. This full end-to-end orchestrated ELT pipeline is now ready for my business teams to overlay a BI dashboard and visualize the data. I hope you enjoyed this comprehensive look at Matillion Data Productivity Cloud. Thanks for watching.